Hi everyone, welcome back. In this tutorial, we're going to learn how to run PostgreSQL inside Docker containers. So far in this series, we've worked with Docker images, containers, networking, volumes, and Docker Compose. Now it's time to start working with real database containers and persistent storage. In this example, we'll run a PostgreSQL database inside Docker, configure environment variables, connect to the database using the terminal, create tables, insert data, and verify data persistence using Docker volumes. Let's explain this command step by step. First, we use docker run. This tells Docker to create and start a new container. Then we use the -d flag. This means detached mode, so the container will run in the background. Next, we use --name postgres-demo. This gives our container a custom name, making it easier to find and manage later. After that, we use environment variables with the -e flag. Postgres_password defines the database administrator password. Postgres_db creates a default database when the PostgreSQL container starts. Then we use -p5432:5432. This maps port 5432 on our local machine to port 5432 inside the PostgreSQL container. And finally, we specify the image name, Postgres. Docker will use this image to create and run the PostgreSQL database container. Since this is the first time we are using the PostgreSQL image, Docker needs to download it from Docker Hub. Docker images are stored in layers, so depending on your internet connection, this process may take a few moments. Once the download is completed, Docker will automatically create and start the PostgreSQL container for us. Now let's verify that the PostgreSQL container is running correctly. Here we can see the container name, image, status, and the exposed PostgreSQL port. Now let's enter the PostgreSQL container using an interactive terminal session. This allows us to interact directly with the database environment running inside the container. Now we are connecting directly to the PostgreSQL database using the psql command line client. Here we specify the Postgres user and connect to the myapp database created automatically when the container started. Now let's create our first table inside the PostgreSQL database. In this example, we are creating a simple users table with an auto-incrementing identifier and a name column. Now let's insert some data into the users table. Here we are adding a sample user record into the PostgreSQL database, and now we can query the table and verify that the data was stored successfully inside the PostgreSQL database container. Now let's exit the PostgreSQL client and leave the container terminal session. Now let's restart the PostgreSQL container. This helps us verify whether the database data persists. Let's enter to a PostgreSQL container again. As we can see, the data still exists after restarting the PostgreSQL container. This demonstrates persistent storage inside the database container. PostgreSQL stores its database files persistently, allowing the data to survive container restarts. Docker automatically creates volumes for PostgreSQL database storage. These volumes allow the database files to persist independently from the container lifecycle. Here we can see the Docker volumes available on the system. In this case, PostgreSQL automatically created a persistent Docker volume to store the database files outside the container lifecycle. Here, inside Docker Desktop, we can also visualize the PostgreSQL container running graphically. We can see the container status, logs, ports, and other Docker resources directly from the interface. Now let's use a graphical database client to connect to our PostgreSQL container. In this example, we'll use DBeaver, which is a very popular free database management tool commonly used by developers, backend engineers, and DevOps teams. I'm currently using macOS, so I'll quickly download and install the Mac version of DBeaver. Now let's create a PostgreSQL connection. Earlier in the video, we exposed PostgreSQL on port 5432 and configured the database credentials using environment variables. So here we'll use localhost as the host, port 5432, database name myapp, username Postgres, and the password secret, which we configured when creating the PostgreSQL container. And as we can see, the connection was successful. Now we can explore the PostgreSQL database graphically. Here we can see the user's table we created earlier. Let's execute a select query to verify the existing data. And we can see the user daily stored inside the PostgreSQL database. Now let's insert another user called Alex. And finally, we can also delete records directly from the database using SQL queries. And now we successfully deleted the record from the PostgreSQL database. Before finishing, let's summarize how PostgreSQL works inside Docker. The PostgreSQL database runs isolated inside a Docker container. Applications and database tools like DBeaver can connect to the database through the exposed PostgreSQL port. Docker also manages persistent storage using volumes so the database data survives container restarts. This approach is very common in modern backend, DevOps, and cloud-native environments. And that's it for this tutorial. Today we learned how to run PostgreSQL inside Docker containers, configure environment variables, connect using the terminal and DBeaver, execute SQL queries, and verify persistent storage using Docker volumes. Thanks for watching, and see you in the next video.